Hello, welcome back to Game Programming with Unity. We're working with audio now. And in this little segment, what I want to do is show you how to create an audio source for an object and edit those parameters. So what I've got here, if you open up your scene, lesson 702, what you'll see is I've got a scene here, just an object in space, right? And then we've got our character over here. And what I'm going to do is I'm going to create an audio source component for my object. Now, audio sources, if they're 3D, must come from a point in space. So we have to create a component for an object to actually play the audio. So let's select our cube here, and I'm going to go to Component, Audio, and create an audio source. We've already seen what an audio listener does. Let's look at the audio source. All right, that means that that object is now going to contain some sort of audio. So let's go ahead and look at the parameters here. All right, first of all, I'm going to load up an audio clip. Now here are some of my audio clips, and I can go through these and start playing them.
Weapon upgrade.
And these are just little sounds I've gotten from various games and projects I've worked on. So these are my actual clips here, which are assets. Now, of course, I can change a lot of the parameters of these assets here about the compression and whether we load them or preload them and things like that. And that's fairly advanced when we talk about how to load assets. Let's go ahead and select our cube. Now let's just drag and drop. And I'm going to use my bell here. It's a good indicator, so it's an annoying sound, but I can really hear whether it gets louder or softer as I get closer, further away from it. All right, so I have loaded in my bell. Now here, this output, we're going to ignore this stuff. This is a lot of effects and things that we could do mixers in, and it may not be available in the free version of Unity. I'm using the pro version here, so I'm just going to leave this stuff alone. All right, so this parameter though, play on awake. This means will this sound play as soon as the game starts? If I do have it on, it will start as soon as the game does. And if I don't, it will not. All right, so let's turn that on. Now, loop means is this sound going to continuously loop? Because the sound either loops or it doesn't. A lot of this stuff we can control in the programming aspect, and you can control from the script, but we really want to be able to have a sound start and continuously play. Like if you have background music, it's really easy just to set it up here and say play on awake and loop. All right, so some of these other things here, we have the volume control. Priority, we're not going to worry about that too much. It's a little bit advanced. All right, pitch here, we can adjust the pitch. So let's just hit play here. And you notice we can change the pitch to -1. It's a little crazy. It's going to play backwards. Or we can play a lot faster. Zero will not play at all. So that we can have a little bit of adjustment over that pitch. It's kind of nice to be able to change that on the fly. All right, what else do we have here? Stereo pan, right and left. Right, so it'll go only to the right speaker, only to the left. And spatial blend. This one's important. Why? Because this turns it from a 2D sound into a 3D sound. If you notice, spatial blend being on 0 means it's a 2D sound. It means it sounds the same no matter where you are in the game. Now I'm going to turn this all the way up here. Ah, that's better, huh? All right, what's happened? Well, what has happened is I've changed it to a 3D sound. Now that 3D sound means that it's going to happen only from the position in space where it is based on the listener, which is on my camera. And my camera happens to be right now connected to my player. So there's my listener. And here's my audio source. Now you notice we can kind of hear it faintly. Why is that? Well, we have what's called a fall off here. All right, so here's our 3D sound settings. Let's not worry about the reverb zone mix. We can create reverb zones, and we can get fairly detailed about audio and reverberation and things. We're going to be a little bit simpler in this particular tutorial. All right, so we had this thing Doppler level. We'll get to that in a minute. But this roll-off, right? Minimum distance and maximum distance, okay? A logarithmic roll-off requires and you see the logarithmic means that it gets steeper as it goes. So the further away you go, the steeper the roll-off gets. Now, logarithmic roll-off means the maximum distance needs to be really far out in order for the sound to fall off. So no matter where I am in the scene, within reason, I can hear that sound. And it depends on the scale and size of your scene. So I'm going to change my maximum distance to 1200. And it should get 200 here. We're not going to see a whole lot of difference. Let's make it 12. There we go. Now see, even though I'm outside of the maximum distance, with a logarithmic roll-off, I'm still going to hear it. And no matter what, because of the steepness of this curve, I'm pretty much going to hear that sound anywhere in that world. Alright, so we can change this to what's called a linear roll-off. There we go. Now, linear roll-off says, much better. Now it's quiet. It says I'm not going to hear this until I get inside this zone here, right? I'm not going to start hearing it until I get inside the zone. In the minimum distance, that's the point at which I can hear the sound 100%. So now that I've changed those, see, I'm entering. If you can see over here, my character is going to enter into the sound zone. Now, he's going to start hearing it at about 50% volume, 50% in between this sphere and this sphere. You see, so as he gets closer to the outskirts, he can't hear it. And the volume in a linear fashion goes up. Now we can also use a custom roll-off, which is kind of nice because we can choose our own roll-off. Just using a simple curve. So it's kind of nice to be able to customize the roll-off of your sound. So I can hear it pretty well here, but it fades off fairly rapidly into the distance. Okay, now you hear that waver? That's our Doppler. And the thing about the Doppler is, as you learned in high school physics, it causes the waves to change length as you get closer or further away. So we're basically creating a Doppler effect. Now, a lot of times it's really distracting. We want to get rid of it. We just drop that Doppler level to something extremely low. Because we don't really know how fast we're moving. So if we're really going to start doing physics calculations about how fast we're moving and what the Doppler effect should be, you can sit down and work out the distances. But really, we just kind of want to get an idea that as we move away from it, the sound will cease to play. So you can imagine in a game, moving closer to an object that's emitting a sound, right? The sound should get louder. Now, you don't always want this to happen, and we can also even blend this spatial blend. So we can hear it a little bit, so we have a little bit of 3D and a little bit of 2D. It's kind of nice to be able to blend them together so we get that effect, but we can kind of pull it back a little bit so we actually hear the sound, even when we're not right up on the object. So this is just kind of a way of how we create the audio component, right? So I've created an audio source. I've told it to play on awake. I've told it to loop that play. And now we went down and said, okay, is it a 3D sound or a 2D sound using the spatial blend? And down here, I'm able to control my 3D settings so I can really tweak the values of that sound and get it working like I really want in the game. I really want this to pop out and immerse the player in the gameplay by creating a three-dimensional audio effect. Okay, so when we come back, we're going to start learning how to do things like scripting the sounds and getting them to play based on events in the game.